We're going to dive into Chapter 7 now. What questions do we have dealing with geometry, guys? Anything on nets? How to visualize when we, break open a three-dimensional shape? Anything from 7.2, dealing with naming points, lines, planes, all that sort of stuff? Biggest thing with linear notations is what you put above it. Are you notating a segment, a ray, or a continuous line? How did this jump back up? Naming angles, just make sure you put it in the right order, vertex in the center. Measuring, yeah.
For the homework, question 13 for 7.2, I didn't get.
This, if EG lies in plane X, that one. So, let's set up the conditions that they're telling us here. If EG lies in plane X and point G lies in plane X, so we need to say whether each statement is always, sometimes, or never true. EG lies in plane X. So, I'm going to draw plane X. Here's a plane named X. Then EG, actually, because it has the arrows above it, I know that it's a continuous line, where just EG are a way to name it, but those are not the endpoints. So then it says point G lies in plane X. Well, does point G lie in plane X?
Yeah.
Does it always have to happen? Will it sometimes happen, or does it never happen? Is there, so what situation would G not be on plane X?
If instead of EG being on the same plane, then being closer, then E could be in plane X, and then G could be in another plane.
You have to remember, that has to happen. Their first statement that they tell us, that's like the requirement. So if EG lies in plane X, so that it has to happen. Then what we're answering is how often does this happen? Always, sometimes, or never, assuming that the first part of my statement has happened. So this always has to happen. If EG is on the plane or in the plane, I like to say on the plane, but they say in the plane because they talk about geometry, things are in things, then point G is going to be on the plane no matter what. Now, if it said EG, connects or goes through, like EG transverses plane X, then maybe G would be on plane X because of the line. Like, imagine this book was my line, and then I, go through the book, right? So G might be on the book, but it might be up here, it might be below, it might be on that plane, but here it's always going to happen. Other questions? 7.2. Yeah. 17.
The way they worded it kind of confused me.
Draw a figure to fit each description. Through any 2 points, there's exactly one line. Point A, point B, there's only one line that can connect them. Then 2 distinct lines can intersect in only 1 point. So distinct lines, let's make a third point. Darn green. Call that C, and if I want C to connect with D, and I make that line, then that intersection, maybe we call it point E, but that's that distinct point. They do not connect in more than 1 point. It's impossible because they're a straight line. So that's all we really have to show. That's how we would draw that. Yeah, so when you read through these, think of how could you reword it. If you were explaining it to somebody else, how might you say it? Because really, A, when I look at that, says, show that I make a line by connecting 2 points. Is really when I read A, that's kind of how I interpret it. And then B, two distinct lines can intersect in only one point. Show that two lines can intersect. And when they do, it's at a point. Now, if I had a curve and a line, like a parabola, then they connect in 2 points or more. Other from 7-2. About 7-3, measuring segments. A lot of this was distance or difference formula. You want to be able to sum your segments. So if you're given two different segments, or if you're given one and then not the other. How do we measure angles? So we can use protractors, or we can use given statements to kind of do the algebra to solve these. Any questions from 7-4? 7-5, exploring angle pairs, those relationships that you should have actually started learning about in 7th grade. Did not mean to click into that. I thought this one was funny. Complementary angles. You're looking good today, as are you, my friend. And these are Greek symbols, by the way, so don't get thrown off when they use those. In math, we just like to use Greek symbols a lot because they're not the American letters that we're used to. Any questions? 7-5. 7-6, finding midpoint and distance. I kind of anticipate there might be some questions here because people have asked me as they've been working. Yeah?
There's a question on the homework where it says, rooms shown below the right is 14 by 10 feet. Find the dimensions of each piece of furniture to the nearest 10.
Talking about this?
Yeah.
So, to find the dimensions, I want length and width, right? So, what we are initially being asked to do is find out what is this, and then what is this for each of these. And the dresser is easy, right? Like that, we probably don't need to go over. But the bed and the table, this makes it a little bit more difficult. Now, what I could do, as my favorite professor would always say, is can I draw a line or connect anything or show anything that will help me solve this? So what I can show initially is this diagonal line really is the hypotenuse of a right triangle. But if I have a right triangle, I know how to solve the hypotenuse length, right? Using the Pythagorean Theorem, which is really the distance formula. Because if I look at the distance formula, the distance is always y2 minus y1 squared plus x2 minus x1 squared. This is just the Pythagorean Theorem. It's a manipulation of it, but it really is just the Pythagorean Theorem. So I figure out where are my 2 points. Well, this is pretty easy. My x is 0, my y is 5. And up here, my x is 5, and my y is 10. I always make my 2 point the one with bigger values. So I'm going to make this my 2 point. So I do 10 minus 5, that'll get squared, plus 5 minus 0, that'll get squared. 10 minus 5 gives me 5, 5 squared is 25. 5 minus 0 still gives me 5, 5 squared is another 25. I get that that distance is a radical 50. I could simplify that. You could break this down to 5 radical 2 if you wanted. And then you could evaluate. That's going to be 5 times about 1.4. So you're going to get like almost 7-ish. Yeah, that's how we would evaluate any of those. Is set up the distance formula or make it a right triangle. I mean, I could use the Pythagorean Theorem in its actual form, but the only difference between that is I would have c squared equals a squared plus b squared. So to get c by itself, I end up doing the square root of a squared plus b squared. And a squared is really just the change in your y values. B squared is really the change in your x values. Obviously still squared, but so that's how they are the exact same thing actually. Does that help?
Yeah.
Okay. Other questions, 7-6. If you want to, on the back of this homework, find the middle of each of the closets, how you find the middle of any rectangular object. Anyone know? How do you find the middle of a rectangle?
You find the length of the diagonal thing and then just find the midpoint of that one.
Yeah, so there's two ways. I can either find the midpoint of my horizontal line and the midpoint of my vertical line, and then that will tell me my XY coordinates for that middle of the closet, or, I forgot I'm on my laptop, it doesn't have the same software package, or I can draw the diagonal here and the diagonal there, and the funny thing is, the midpoint of my one diagonal will be the midpoint of my other diagonal. So if I just draw this diagonal, I can just find the midpoint using this endpoint and this endpoint, and I could just find a single midpoint, and that's the middle of my closet. So if I just use the midpoint formula to try to calculate that midpoint, I could use this value of 0.9 and this value of 5.4, and I can find the midpoint between the two of them, and that's the center of the closet. So because people had asked me about that, I thought I would touch on that really quick. Just finding midpoints of rectangles. Or middles, not just midpoints. I think that's almost the end of the chapter. That is the end of the chapter. Any other chapter 7 questions? All right, so at this point, we're going to break up into independent work time, but like I said at the beginning of class,